Hello and welcome to Precalculus lesson number 31. In this video, we're going to learn about determinant solutions of systems of linear equations. Given that a determinant is a quantity associated with what is called a matrix, we'll first take a look at what a matrix is, but we will not be delving too deeply into matrices and their properties or operations, etc. That is handled in a class called linear algebra, in case you may be interested in taking such a class or someday required to take it. But we will try to understand enough about a matrix so that we can go ahead and define a determinant and accomplish what we need to accomplish in this lesson. A matrix, whose plural is matrices, is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns, as you can see down here, which is used to represent a mathematical object or a property of such an object. The size of a matrix is determined by the number of rows and columns. Okay? A matrix with m rows and n columns is referred to as an m by n matrix. So here we can see a 2 by 3 matrix. Remember, we first say the number of rows which are arranged horizontally, then we say the number of columns which are arranged vertically. So this would be a 2 by 3 matrix. This would be a 3 by 2 matrix because it has 3 rows and 2 columns. And here we have a 3 by 3 matrix. These kinds of matrices, as we see, are special. They're called square matrices. The elements of a matrix are named according to their location in the matrix. For example, the element in the second row and fourth column of a matrix would be referred to as A with a subscript 2, 4. And the element in the third row and the third column of a matrix would be referred to as A, 3, 3. So you see A, 3, 3, for example, in this matrix. And here's A22 because this element is in the second row and the second column. Here's an element A21 because it's in the second row and first column, right? So first the row number and then the column number. As I indicated, a square matrix is an n by n matrix with the same number of rows and columns. In this section, we're solely interested in square matrices, given that there is a real number called the determinant associated with every n by n matrix that can help us solve most systems of n equations in n unknowns in a quick and efficient manner. Now, we're primarily going to be dealing with 2 by 2 and 3 by 3 square matrices. So let A be this 2 by 2 matrix and let B be this 3 by 3 matrix, as you can see here. We're going to define the way you need to calculate a determinant for each of these types of matrices. So the determinant of A, matrix A, whose notation looks like the absolute value, but it's not. Because it's a matrix, you realize that you should be pronouncing that as determinant of A, right? Is calculated in this very simple manner. Basically, you do two diagonal products and you subtract them. First, you find this product, going from left to right, and then you subtract from that this product, the BC product, which is the product going from right to left, right, this diagonal. All right, so AD minus BC gives you the determinant of A. Now, the way you find what's called the determinant of B is going to be a little bit different. What you're going to do is you're going to write the original matrix determinant. Well, matrix is associated with it, but we're looking at a determinant. And then you repeat the first two rows on the side here, okay? This is just for assisting us to find this determinant. And then what you do is you take these diagonal products. So first, going from left to right like this, AEI, you add to that BFG, and then CDH, like that. And then you take away from that each of these products going the other way. So CEG, AFH, and BDI. Now, we put this in a parenthesis like this because this minus needs to be distributed. So basically, it's going to be minus CEG minus AFH minus BDI. And this right here is actually what's considered to be a shortcut method to finding determinants. The regular method would actually involve what's called cofactors and the 2x2 matrices for each cofactor. But for our purposes, like I said, we're not a linear algebra class. I just want you to have enough information about determinants to be able to solve systems of equations. So this will more than suffice for our purposes. So one easy way to remember how to calculate 3x3 determinants is realize that these products that you're going from left to right, remember right is usually associated with positive, so add those, and these products which appear to be going from right to left, and we usually associate left with negative, right? So subtract those and you'll get the value of the determinant. So that's just a visual to help you remember it. All right, so here we're going to calculate this 2x2 determinant, and that of course is easy. We're just going to multiply -6 by -1, and we're going to subtract from that the product of 4 and 6, right? So that's going to be 6 minus 24, which is going to be -18, and that's all there is to that. Okay, so for this one, remember we're going to repeat the first two columns on the side here. So make sure you leave a little bit of space so that it's easy to see the products. So 2, 8, 6, and then 5, 0, 4. All right, so we're going to, it's a kind of a good idea to do this kind of thing for yourself. All right, so those are going to get added, remember? And then these other ones are going to get subtracted. So we get 2 times 0 times -3 plus 5 times 6 times 6, and then plus -1 times 8 times 4. And now we're going to start subtracting the red products, right? So minus 5 times 8 times -3, and then minus 2 times 6 times 4, and then minus quantity -1 times 0 times 6. Now, I mean, it doesn't matter if you start with this one and move this way, or with this one move that way. It makes no difference. All right, so the very first one here we can see is just 0, right? So 0 plus, so we just get 5 times 6, which is 30, times 6, which is 180. And then positive times negative is going to give us a negative, and these are positive too, so they're not going to change anything. So minus 32. Now here we have negative times negative, that's positive, and that's 40 times 3, so plus 120. Then we have minus 8 times 6, which is 48. And then this one, of course, is also just 0, right? So we don't need to write minus 0. Okay, and now we're just going to compute that, right? So we have 180 minus 32 plus 120 minus 48. And computing all that gives us 220. All right, so notice that instead of writing this product plus this product plus this product minus quantity and then this sum, we just went ahead and distributed the minuses, right? So we didn't need to go for two steps. We just saved one step by just realizing that each of these products in the red is just going to get subtracted, right? And that's all you have to do to find that determinant. All right, go ahead and try this one, see what you come up with, and then come back and watch the rest. All right, so remember we repeat the first two columns. So 0, 6, and 6. All right, and then we're going to go ahead and mark these for simplicity. And we'll add the green ones, and we'll go ahead and subtract the red ones. The products, of course, is what we're talking about. All right, so this product gives us -1 times 6 times 10. Plus this product, which is of course going to be what? 0. We don't need to write much more than that. Plus this product, which is -1 times 2 times 6. Now we start subtracting. I'll go this way this time. Start with this one. -1 times 6 times 10. Minus this product, -1 times 2 times 6. And then minus this product. As you can see, if there's 1 0, the whole thing product is going to become 0. So -0, right? So notice something interesting. You have -1 times 6 times 10, and then minus the exact same thing. And then you have -1 times 2 times 6 minus the exact same thing. So you don't really need to be doing much computation here, do you? You don't need to multiply those out. You just know this answer is going to be what? 0. All right, so there's another 3 by 3 that we handled. All right, so make sure you're comfortable with this business of determinants, and we'll proceed. Next, we're going to look at the rule that's going to help us solve systems of linear equations. First, we'll start with two linear equations in two unknowns, and it's called Cramer's rule, and basically it states that this kind of a system, composed of two linear equations, a1x plus b1y equals c1, a2x plus b2y equals c2, with of course a, b, c with the subscripts being the constants and x and y being our variables, can be solved using the following quotients. For x, what we do is on the bottom here we will have a determinant composed of the coefficients from the left side of these two equations. Now it's extremely important that before you apply Cramer's rule, you do put both equations in this format. So with the x and y on one side, constant on the other side, even if the constant is 0, right? So Make sure you do that, and then you're ready to form your determinants. Notice that for both x and y, the bottom determinant is the same, and it's composed of the coefficients from the left side of these two equations. So a1, a2, b1, b2, see? Same thing. Now, to get the top determinant, what you do is the following. Whatever variable it is that you're solving for, like x here, what you do is you replace the coefficients of that variable with the numbers, the constants on the right side. So c1, c2 here goes instead of the coefficients for x, and you keep the coefficients for the other variable. So solving for y, you keep the x coefficients and you replace the y coefficients with the constants from the other side of the two equations, okay? And you go ahead and solve. So we call this determinant up here capital Dx, and the determinant that's common to both solutions we call just capital D, okay? Now this of course will yield results as long as capital D does not end up being 0. If it does end up being 0, doesn't necessarily mean there's no solution. It just means you can't use Cramer's rule to solve the system, so you should approach the system using another method. Okay, so here we're going to solve this system using Cramer's rule. It's a system of two equations and two unknowns. So we are in the right format. We always want to check for that. First, x and y on the left side and a constant on the right side. X and y terms on the left side, constant on the right side in both equations. So here we go. So for x, and y, for both of them, we know that the denominator, the bottom determinant, is going to be the one composed of the coefficients from the left side of these two equations. So 1, 1, 1, negative 1, right? So that's the easy part. We'll go ahead and write those. All right, for x, on the top for the determinant called dx, we're going to replace the coefficients for x with the constants from the other side. So 3, 1, and we will keep the coefficients for y. So 1, negative 1, okay? When we solve for y, we're going to keep the coefficients for x. So this column doesn't change for relative to what we call d. But for the coefficients of y, we replace the 1 and negative 1 with 3, 1. And then we proceed to solve. So this determinant is of course going to be 3 times negative 1 minus 1 times 1, and the bottom determinant is going to be negative 1 times 1 minus 1 times 1, right? So we're going to end up with negative 3 minus 1 over negative 1 minus 1. So that's going to be negative 4 over negative 2, which is going to be positive 2, okay? So for this one, you probably know how to handle it, so go ahead and pause and try it and then come back. So 1 times 1 minus 3 times 1, right? Down below we have 1 times negative 1. Let's just put negative 1 minus 1 times 1, which is 1. So we end up with 1 minus 3 over negative 2, right? Which is negative 2 over negative 2, which is 1. So now we have the x and y, so we can write the solution set. It's going to be the set containing the ordered pair 2, 1. Remember, you always give solutions of systems as ordered pairs. And that's it. So very nice, very quick, very easy. All right, so as you gain more and more experience with these, you start to realize maybe it's best if you calculate capital D first, because then you won't waste time doing a lot of writing if it ends up being 0, right? So let's try that first. Let's go ahead and find what we call capital D, which is just the coefficients from the left side, right? So 318, 7, 42. I'm, of course, reading the columns, right? So we end up with 3 times 42 minus 18 times 7, or 7 times 18, makes no difference. So let's see, 3 times 40, that's 120, and 3 times 2 is 6, so 126. 7 times 18, let me show you a nice little trick. You can think of 7 times 18 as 7 times 20 minus 2, right? So that's 140, take away 14, so that's also what? 126. And notice you end up with 0. So that means you should go ahead and try another method for solving this system. It usually indicates that you're either going to have no solution or infinitely many solutions. Let's see which one this turns out to be. So you know, this is a system which does not have any terms with a coefficient of 1, so substitution is not a particularly good method for this problem. We'll go ahead and solve it using elimination. So we'll go ahead and multiply the top equation by -6. That gives us -18x minus 42y equals -30. And 18x plus 42y equals 2. We go ahead and add the equations. Both of these zero out, so we get 0 on the left side equals -28, which is of course a contradiction. So now we know that this system has no solution. In case somebody asks you for the number of solutions, what do you say? 0. Remember, that is not a solution. That's the number of solutions. How many solutions do you have? None. So how do you say that? Well, that's 0 many solutions, right? All right, so that's what happens if you end up with a 0 in the denominator. Notice that sometimes you end up with a 0 with systems that have infinitely many solutions as well. Look at this simple example. X plus y equals 1. I'm just going to multiply both sides by 2. So 2x plus 2y equals 2. So if I had a system like that, notice that the determinant, the capital D for this problem would be 1, 2, 1, 2. So that would be 2 times 1 minus 2 times 1, which is also 0. So don't always assume that just because the determinant became 0, that means you have no solution. You could also have what? Infinitely many solutions. So you know that to write the solution sets of this kind of a system, you would actually just solve one of the equations, like say this one, solve it for y, which gives you 1 minus x. You would write the solution set as the set containing ordered pairs of the form x, 1 minus x, for instance. Okay, so that would be another possibility where the capital D ends up being 0. So we handle 3 by 3s in exactly the same way, okay? So we form our bottom determinants. They're all the same, whether we're solving for x, y, or z, and they're composed of these coefficients from the left side of these equations that have all been put in the proper format, which is what? All the variable terms on one side in that order, x, y, z, or whatever alphabet letters you're using, and then constant on the other side, right? So notice the bottom determinants are the same for all three variables, ratios that are going to give us the solution. So A1, A2, A3, B1, B2, B3, C1, C2, C3, right? Now, to solve for x, you do the same thing we did with 2 by 2s. Replace the coefficients of x here with the constants from the other side. But you keep the coefficients of y and z, so those stay the same and where they are, right? For y, of course, we do the same thing. We replace the y coefficients with d1, d2, d3, and the x and z coefficients stay the same. And finally, for z, we replace the z coefficients with d1, d2, d3, keep the x and y coefficients. And once again, this will yield results as long as the system has one solution. With the cases of no solution or infinitely many solutions, you may end up with d being 0, in which you'll just use another method to determine which case you have. Okay, so before we waste a lot of time setting up a bunch of fancy determinants, let's go ahead and make sure that the main determinant d is not 0. So d is going to be 291. I'm going to be reading the columns, right? Negative 126. That's the second column, and the third column is 6, negative 1, 2. Remember, we replace the first, we repeat the first two columns, 2, 9, 1, and negative 1, 2, 6. Now we're going to go ahead and draw our lines that are going to help us keep the right numbers together. And we have this other set, the group, the red group, right? Remember, we add the members of the green group and we subtract the product in the red group, right? So we end up with 2 times 2 times 2, which is 2 cubed basically, and then plus negative 1 times negative 1, which is 1 times 1, which is 1, right? And then 6 times 6 times 9, right? So 36 times 9, $324. So plus 324. All right. So now we're ready for the negative products. So 6 times 2 times 1, that's minus 12. 6 times 2 times negative 1, so minus quantity negative 12. And then minus 2 times 9 times negative 1, that's going to be negative 18, so minus quantity negative 18, right? So we end up with 8 plus 1 plus 324 minus 12 plus 12 plus 18. Now these of course will cancel out. We don't need to waste time on them. So we'll compute the rest. Okay, so we have 8 plus 1 plus 3, 2, 4 plus 18. So that gives us 351. So it is not 0. We can go ahead and proceed, right? Now remember, for solving x, the top determinant is going to be replace the coefficients of x with these constants here. So -6, -57, 21, but y and z keep their coefficients, right? So -1, 2. I mean, 6, and 6, -1, 2. Now the denominator, we already know it's going to be 351, right? We don't need to write that again. All right, so let's go ahead and be lazy and just do what we need to write here. So -6, -57, and 21, and then -1, 2, 6. So we're gonna have the green group right here. These three groups, right? And we're going to have the red group like so. All right. So we end up with x equals -6 times 2 times 2. That's going to be -6 times 4, so -24. Plus, remember the green group gets added. -1 times -1 times 21, so that's 21. And then plus 6 times 6 times -57, so that's 36 times -57. Yeah, the numbers may get large, but no fear, because we're going to use a calculator, right? And then minus this product, 21 times 2, 42 times 6. And then minus this product, which is 6 times -1, which is -6 times -6, which is 36. And then -2 times -57. So minus quantity -2 times -57, right? And then all of that over 351. Okay, so now our friend comes in and takes care of the rest. So we're gonna have a fraction, right? So I'm gonna go ahead and hit that first, and I'm gonna clear the answer on the top. So I'll make sure to, sometimes you have to push the down arrow to get put in the right spot. And we'll get rid of the A and S. That's the answer from the previous step. We don't want that. We want new information. So -24 plus 21 plus times minus. That's going to give us minus. So let's just put minus 36 times 57. And then minus 42 times 6. Minus 36, and negative times negative times negative, that's 3 negative factors, so it's going to be a negative, so minus 2 times 57. And down below, of course, we already know we have what? We have 351. And then we go ahead and hit enter. So that gives us negative 7 for x. Okay, now we're going to find y. So we do something very similar, right? So y is going to be, all right, remember we're going to replace the y column with negative 6, negative 57, 21, but we keep the x and z columns. So 2, 9, 1, negative 6, negative 57, 21 instead of the y coefficients, and 6, negative 1, 2 stays for the z coefficients. All right, so it does pay to quickly make sure you've done this correctly each time, right? All right, so now I'm going to repeat the first 2 rows. I put that last one a little bit too close. It was kind of hard to see the product, so I'll create more space here. And negative 6, negative 57, and 21. If we put adequate space, not too much either, then it'll be very easy to see your products, right? So our positive products are going to be this one, and this one, right? We're going to add those. And our negative ones are going to be this one, and this one, right? Okay, so now that we know what the denominator is, the bottom matrix D is 351. So that's one of the good things about going ahead and calculating that to begin with anyway, because we're just going to keep, instead of having to keep writing this determinant, we can just write what? The number. All right, so we end up with y equals, all right, so here we have 4 times negative 57. Then we have negative 6 times negative 1, which is 6 times 1, which is 6, so plus 6. Then we have plus 6 times 9 times 21, so plus 54 times 21. Now, if your times table is a little rusty, then just write 6 times 9 times 21, okay? Don't need to try to do too much in your head. All right, and now we're ready to subtract. So the red group, so minus 6 times negative 57 times 1. And then minus 18 times negative 6. No, wait, hold on, this one. Negative 2 times 21. So minus, be careful, you need the minus there as well. Negative 2 times 21. And then minus 2 times 9, 18 times negative 6. And then all of that will be over 351, okay? So now we're ready to plug in again. Okay, so again, I'll go ahead and start with a fraction, but I'll delete the numerator that comes up. And I'm ready to type in. Okay, so 4 times negative 57. Make sure you use that when you want to say a negative number, not that. All right, and then plus So make sure you get out of the parentheses, plus 6 plus 54 times 21. They're both positive. We don't need parentheses there. So minus 6 times quantity negative 57. We should put a parenthesis here. Okay, so negative 57. And notice that here negative times negative gives us positive. I could have done it here too, but I didn't, but I'll do it here. So plus 2 times 21 and then minus 18 times negative 6, so that's going to become plus, right? So plus 18 times 6, okay? Now down below, we know we have 351. We go ahead and hit enter and we get 4. So there's the y value for 4. Now, I'm sure it has occurred to you already that we don't need to do this again for z, do we? If it hadn't occurred to you, pause the video for a minute. Think about why it is that we shouldn't have to do this again for z. All right, because I'm sure you realize we're solving 3 equations in 3 unknowns, and we already have 2 other unknowns. All we need to do is take this x and this y, plug it into any of the 3 equations to get a z. And it makes no difference which one. I'll just go with this one. It has nice small numbers in it, coefficients in it, right? So x, I'm going to replace x with negative 7 plus 6 times y, which we'll replace with 4, plus 2z equals 21, right? So we get 2z, negative 7 plus 24 is 17, so plus 17 equals 21. So 2z equals 21 minus 17, which is 4, so z equals 2. Now we have all our values, and we can write our solution set, which should be the ordered pair x first, so negative 7, then y, so 4, and then z. And there we have it. So there is an application of the Cramer's rule to a system of 3 equations in 3 unknowns. So make sure you can carry out something like that on your own, and we'll go ahead and proceed. All right, here's another problem we're going to try using Cramer's rule. If you notice, these equations are not in the proper format. That's what we're going to do first. So let's go ahead and put them all in proper format. See if you can do it on your own. So 2x minus 6y plus z equals what? Negative 6. We're going to move the constants to the other side. And the second equation becomes negative 7x plus 9y plus 5z is equal to negative 30, and 6x minus 7y minus z is equal to 6. Now, one thing I wanted to mention to you even on the last problem, and I forgot, but I will do it now, is always look out for constant factors that can be divided off from both sides of any of the equations to make the equations simpler. Here, of course, we don't have any. The GCF of all those numbers is just 1. The GCF of all those coefficients is 1, and so is the GCF of all those coefficients, and of course the constant on the right side. But if there's a number that goes into all those coefficients and the constant, you can divide it off and your numbers will be smaller and easier to work with. Okay, so let's go ahead, now that we have it in the proper format, go ahead and calculate D. Now D here is going to be the determinant composed of all the coefficients of the variables. So 2, -7, 6, -6, 9, -7, 1, 5, -1, right? Please do yourself the favor of quickly double checking to make sure you've chosen the right numbers, because this is very important, because if this one is wrong, they're all going to be wrong, right? So because you're going to be dividing each of those top determinants by this value, so make sure you get this one correctly. So 2, -7, 6, -6, 9, -7, 1, 5, -1. So look at this one, not at this equation. 1, 5, -1. Okay, so we're going to repeat the first two columns. So 2, put a little space, 2, -7, 6, and -6, 9, and -7. Now we'll form our green group. And then we'll form our red group. All right, remember we add the green ones and then subtract the red ones from that sum. So we get, here we have 2 times 9 times -1. So that's easy, we'll just do it. It's -18. Okay, for the next one we have 30 times -6, so that's -180. So plus and -180, that's just -180. And -7 times -7 is 49 times 1 is 49, so plus 49. Now we go ahead and subtract the red group members. So minus 9 times 6, that's 54. 2 times 5 is 10 times -7 is -70. So minus -70, which becomes plus 70, right? And then negative times negative times negative is negative, and that's going to be 42. So minus -42 becomes plus 42, right? All right. So let's go ahead and compute that. All right, so 18 minus 180 plus 49 minus 54 plus 70 plus 42, right? So we end up with -55. And that's our D. All right, so now we're ready to go ahead and proceed. So for X, we know that the top determinant is going to replace the coefficient for X with these, -6, -36. And we keep the coefficients of Y and Z. So -6, 9, -7. 1, 5, negative 1. And now we repeat the first two columns. Now, if you go into a linear algebra class, they'll show you a lot of tricks with determinants that you can use to make things simpler, but we're not really spending all that kind of time on this material here, so this will be sufficient for us. All right, and we know the denominator is going to be negative 55, right? So now we create our green group. And our red group. All right, so we have negative 9 times 6 times negative 1, that's positive 54. Negative 30 times negative 7, that's positive 210. Oh, we missed this one in the middle. So negative 9 times 6 times negative 1, let's see, that's positive 54. So we need this minus 180 as well. It doesn't matter the order, so just make sure you don't miss any. So that's going to be minus 180. Now for the red group, we're going to subtract this, which is 9 times 6, so that's minus 54. Here we're going to have 30 times 7, that's 210, and it's negative times negative, so it's positive, so minus 210. And here we have negative times negative times negative, which is going to be negative 180, so minus negative 180 becomes plus 180 over negative 55. All right, it does look like we're not going to need the calculator. Notice that this 210 cancels that 210. This negative 180 cancels that 180. And of course, the 54 cancels the negative 54. So we actually have 0 on the top. What's 0 over negative 55? I think I heard you say 0. I agree. So there it is. X is 0. Now we do the same thing for y. So this time we're going to replace the coefficients for y, right? But we keep the x and z coefficients. So 2, negative 7, 6. And we replace the coefficients of y with negative 6, negative 36. And for z, we have 1, 5, negative 1. Down below, we know we're going to have negative 55. So we repeat the first two columns here. So 2, negative 7, 6. And negative 6, negative 36. Okay, so we go ahead and form our green group. And then the red group. Okay, so we're ready. So starting with the green group, we have 2 times negative 30 times negative 1. That's going to be positive 60. And then 6 times 5 is 30 times negative 6 is negative 180. So plus negative 180, that's just minus 180. and then 6 times negative 7 is negative 42 times 1 is negative 42, so plus negative 42, so that's just minus 42. Now for our red group, we're going to subtract these guys, so that's going to be minus negative 180, so that becomes plus 180. And then 2 times 5 is 10, times 6 is 60, so minus 60. And then negative 1 times negative 7 times negative 6, that's going to be negative 42. Minus a negative 42 becomes plus 42, all over negative 55. Again, we can see 60 cancels negative 60, negative 42 cancels 42, negative 180 cancels 180, so we end up with 0 again. Okay, so all that's left is finding that last variable z. I can go into any of the equations. I'll just go into this bottom one, okay? So 6 times, I'm going to use 0 for x and 0 for y, right? So 6 times 0 minus 7 times 0 minus z equals 6. So that's going to be 0 minus 0, which is just 0. So we get negative z equals 6. So z equals what? Negative 6. Just multiply both sides by negative 1. Now we're ready to write our solution set, which is going to be composed of the ordered pair. X first, 0, then y, 0, and then z, negative 6. All right, so there it is. There's another one. Go ahead and make sure you're comfortable with that, and we'll proceed. All right, so here's another one, and you can see with this we have some missing terms. That's still okay. We can still use Cramer's rule, but we have to make sure that we put this in proper format first. So remember that the first equation can be rewritten as x plus 4y plus 0z equals 18, right? If you get the idea, go ahead and finish it on your own. Next one, I'm going to do two things. First of all, I notice there's a common factor of 2, right? So let me divide those off, so I get 4x. There is no y term, so I'm going to put plus 0y, and I'm going to divide the 2z by 2, so I get plus z equals, and remember we have to divide both sides by 2. See, that makes our numbers smaller, and that's better. All right. So on the last one, we're going to write it as 0x minus y minus z equals 2. So just do a quick scan, make sure you've done it correctly. X plus 4y plus 0z equals 18, that's correct. We divided all of these by 2, so 4x plus, there was no y term, so we put the filler, plus 0y, plus this one divided by 2 becomes z, and this becomes 6, all right? And we don't have an x term here, so we put the filler 0x minus y minus z equals 2. All right, so now we're ready to calculate d. And that's going to be the determinant. We're going to use these values in the new one because they're the proper ones to use. Okay, so 1, 4, 0. 4, 0, negative 1. And 0, 1, negative 1. All right, so we'll repeat the first two columns, 1, 4, 0, and then 4, 0, negative 1. We'll form the green group. And the red group. And we'll proceed. Okay, so you can see, you can probably guess we're going to have a lot of zeros, right? Which is nice. So that's 0 plus 0 plus 0. So the green group gives us 0. Minus, there's a 0. I don't need to write it. And then there's 1 times 1 times -1. So that's -1. And it's minus a -1. So it becomes +1. And the next one is 4 times 4 is 16, -16. So minus a -16 becomes +16. And that's it, right? We didn't miss any, guys, right? So we got this one. We got that one. This was 0. Yeah, we should be good to go. All right, so that's going to be 17. That's our capital D. Okay, so now we need to find X, which is going to be the determinant. Let me actually give myself a little more space. All right, so for the X, the determinant on the top, we're going to replace the X coefficients with these. So 18, 6, -2. I mean, +2. And then the Y and Z coefficients remain. So 4, 0, -1. And 0, 1, -1. Quick check. 18, 6, 2 for X, 4, 0, -1, and 0, 1, -1. So now we repeat the first two columns. So 18, 6, 2, and 4, 0, -1. All right, we form the green group. And the red group. And we know that the denominator is just going to be 17. All right, so we have 18 times 0 times -1, that's just 0. 4 times 1 times 2, that's 8, so +8. This one is going to be 0, right? So +0. I mean, we don't have to write it, but just so we know what goes where. Minus 0, right? Minus a -18, so that becomes +18, correct? And then minus -24, so that becomes +24. And all of that over what? 17. So now we're just going to compute this. We don't need to worry about the zeros, but 8 plus 18 plus 24. So we get 50. So X is going to be 50 over 17. All right, next we'll compute Y. I'll move. The denominator is just 17, so I don't need space for that. All right. So for Y, we're going to replace the Y coefficients with those, but the X and Z stay the same. So 1, 4, 0, 0, 1, -1 stay the same. We're going to replace the Y ones with 18, 6, and 2. Repeat the first two columns on the side here. 1, 4, 0, and 18, 6, 2. Okay, so we'll go ahead and form the green group, and then the red group. All right, so we'll add the products in the green group and then subtract the products in the red group. So we have -6 times 1, which is -6. 18 times 1 times 0, that's just 0. And 0 times 4 times 2 is, of course, 0. Now we're ready to subtract. So the first one product is 0. Second one is 2, so -2. And the third one is going to be -4 times 18 is 72. So minus -72 becomes plus 72 all over 17. So we have the zeros are just not going to do anything for us. So 72 minus 2 is 70, minus 6 is 64 over 17. Okay, so there is y. So we have x here, 50 over 7, and we have y, 64 over 17. Now we can take these two and go in the original equations, or these, doesn't matter, and get the value of z. I notice if I use the third equation, I'm only going to need to bring in the y. So that's what we're going to do. So we have negative y, which we're going to replace with 64 over 17. So negative 64 over 17 minus z is equal to 2. Let's go ahead and multiply both sides by 17 to clear the fraction. So we get negative 64 minus 17z is equal to 34. Let's move the negative 17z to the right side to make it positive 17z. And we'll move the 34 to the left side to make it negative 34. And now we have negative 98 equals 17z. Divide both sides by 17 and we get z equals negative 98 over 17. All right, so I wanted to do this problem because I don't want you to panic if you see fractions. There's no difference. You treat them just like a problem with integers in it. So we get the solution set composing of the ordered pair x first, so 50 over 17, comma y, 64 over 17, and then finally z, which is negative 98 over 17. All right. In case of curiosity, you can plug these in, at least using a calculator, even if you don't want to do it by hand, into these equations, and you'll see that it will satisfy all three of those equations. Okay, so there's yet one more. Go ahead and get comfortable with that and we'll proceed. Next, we want to look at a really nice determinant that kind of plays the same role as Heron's formula, which you may remember from your trigonometry class, that allowed you to find the area of any triangle without involving sines and cosines in the formula. So here's another method that can be used to find the area of a triangle using this determinant. Notice that the x1, y1, for example, will be the coordinates from this point. Pick your, whichever you like, but just to be systematic from left to right, we'll use x2, y2 for to replace these with, and x3, y3 will replace with 1, 4. Okay, and we can just figure out the determinant, and that will give us the area. Try it and see what you do before you come back and watch the rest. So we get now, do be careful. You have to take the absolute value of what this is. If this turns out to be a negative number, you can just take the absolute value and that will still generate the area. So here we have 1/2 times this determinant. So we're going to put 0 and 0 for the x1, y1, and then 1. For x2, y2, we're going to use 6 and 8. x3, y3, we're going to use 1, 4, and then 1. All right, so as usual, we'll go ahead and repeat the first two columns. And we go ahead and form the green group. And the red group. All right, so we have, don't forget to bring the 1/2 over as well. So 1/2 times, now this product is 0, that product is 0, so basically 0 plus 0, and that product is 24. I should probably use a bracket here. And then minus, that's going to be 8. That product is 0, and so is that. So minus 0, minus 0. So it's going to be 1/2 times, that's going to be 24 minus 8, so that's going to be 16, right? So that's going to be 8. Obviously 8 square units, depending on whatever units are at work here. And that's the area. Now, this could become very handy in case you have, say, you own a, rectangular piece of a land or something like that. You want to quickly calculate the area. As long as you can get some coordinates, you will be able to do so. So that should pretty much wrap it for this lesson. A very, very quick, nice way of solving systems of equations using determinants. All right, you take care until we meet for the next lesson.